Um, in this video, we want to understand and to learn how to derive quadratic formula before we know how to use it. It is important to know how to derive a quadratic formula. Of course, in the textbooks, it is not derived. I think, it is derived sometimes, but at this particular point, I would want to teach you how to derive quadratic formula. And as such, let's begin there. The general quadratic equation is ax squared plus bx plus c is equals to 0. And we all know that a quadratic formula from year 11, which I introduced and you all got lost. Here we learn how to use it. X is equals to minus b plus or minus the root of b squared minus 4ac and everything over 2a. It is important to know how do we get here, how do we make x the subject of the formula. Of course, from this equation, we realize that c being a constant, it has to go on the other side because we want to complete the square of the left hand side. So we start by saying ax squared plus bx is equals to negative c. And because we have a coefficient of x squared which is a, the best way to complete the square is when we have a as 1. So we will get a outside as a factor and have a outside, x squared plus bx, of course, over a, such that when we open this bracket, then we'll be left with what we had, bx, which is still equals to negative c. So completing the square of the bracketed part, we have, of course, we know we know generally if you have x squared plus bx, to complete the square we have x plus b over 2 squared minus b over 2 squared. That is not new. And of course, at this particular point, we complete the square of the bracketed part. We have x plus the coefficient of x is b over a. So b over a over times a half, or rather over 2, is b over 2a squared minus b over 2a squared, because we are following this method. Of course, the whole of this is multiplied by a is equals to minus c. Fine. If we wish now to open this bracket, you're going to find something that looks like this. A affect the first bracket, x plus b over 2a still squared, minus, when you open this bracket, you're going to have b squared over 4a squared multiplied by a, which gives you negative c. Moving forward, you will be able to see that when you open this bracket, you're going to have a x plus b over 2a squared minus b squared over 4a. Over 4a now, it's not 4a squared because 1a will cancel with the other a is equals to negative c. Fine, if you divide everything at this particular point, divide everything by a on both sides, you are going to have something that looks like dividing by a, you're going to have something that looks like x plus b over 2a. Of course, it continues to be squared, minus b squared over 4a divided by a means 1 times 1 over a, of course, is equals to minus c over a. At this point, we have x plus b over 2a squared minus b squared over 4a squared minus b squared over 4a squared, which is still equals to minus c. But at this point now, we can have x plus b over 2a still squared is equals to, if you bring this, the whole of this part across, the whole of this part is equals to b squared over 4a squared minus c over a, getting the square root of both sides. We have x plus b over 2a is equals to the square root of b squared. Of course, you ought to have combined the two, which should have given you the LCM is 4a squared divided by this denominator, getting 1 times b squared minus 4a squared divided by a. It gives you 4a times c minus 4ac. So this is the part we are getting the square root of, at least so that we can balance the two sides. So minus 4b squared minus 4ac, everything over 2a. And the root over 4a squared, rather. 4a squared. And the root, as you can know, we understood from a previous video that the root of a over b is the root of a over the root of b. That knowledge will be applied here. So we are going to have x plus b over 2a is equals to the root of b squared minus 4ac over the root of the denominator, which is quite terminating, it's quite perfect. So the reason why we have applied this method is because we can see we can have a terminating square root of the denominator, which is 2a. And at that particular point, we realize that if you bring b over 2a across, you're going to have x is equal to minus b over 2a. Of course, the square root of any number is plus or minus. So plus or minus the root of b squared minus 4ac, everything over 2a. And because they share the same denominator, so we can easily have our x finally to be equals to minus b plus or minus the square root of b squared minus 4ac, everything or the whole of right hand side over 2a. And that now becomes the quadratic formula as we know it. So this one, as you can see, becomes the quadratic formula as we know it. So it is very important to know how to derive the quadratic formula before we understand how to use it. And that is why I found it important to explain to you how we move from here all the way to this particular point. Okay?